which boasts of 112 scientific papers, 65 peer-reviewed papers published in index journals. He was also the head of the Department of Audiology at AISH for a period of 3 years, and he's won the Young Scientist International Travel Grant and received certification course training in CAPD from ASHA USA and advanced audiology course training from ICIT USA in 2021. So now I request Dr. Praveen Kumar to please start his talk.
Thank you, Dr. Neeraj. Good morning, everyone. I hope I'm audible. Could you set the timing? It's showing 5 minutes here. It's fine. Timer is fine. So, thank you, Dr. Neeraj, for introduction. So, I'm going to talk about computer-based auditory training for children with APD, evidence-based practice. This particular topic is very close to my heart, and I'm thankful to Professor Ashay Kidas, who was my mentor, and I constantly keep on learning from last 2 decades this particular topic from the year 2004 to till date. So, since the topic is majorly focusing on management, and one of the areas in the management of APD is auditory training, and in that computer-based auditory training is something which is a need of the hour. So I will not go into the assessment and other domains of the APD. So when it comes to the APD, auditory processing disorders, it defined as deficit in the neural processing of auditory information in the central auditory nervous system, which is not due to higher order language or cognitions. Further, it is also manifested as having difficulty in processing certain auditory information despite having normal hearing sensitivity. So remember, when you use the term APD, there you may have, with and without hearing loss. I'm talking about older individuals, but then when we are talking about CAPD, it's considered as, the peripheral auditory system is not affected, and its lesion, the functional impairment is majorly into the central areas. So, when we talk about computer-based auditory training, this is one of the direct intervention method. Apart from that, all of us must be aware of it. We do talk about environmental modification and anticipatory strategies, but my focus today in this presentation is on direct intervention method, auditory training, which is considered to minimize the listening difficulties caused by an APD and its impact on learning and communication. Auditory training optimizes the neural circuit by selecting the number of neural population and synaptic connections engaged in the concerned processes along with the temporal synchrony of the neurons. Auditory training may involve the activation of inactive neural connections and formation of more efficient synaptic connections. Changes in neural substrate are often associated with behavioral changes as reflected in measures of listening performance, that is auditory processing test. The thing is, why do we think computer-based auditory training is effective for APD children? So we are aware of it that neuroplasticity, which is one of the reasons to understand that CBAP works. And we know very well that brain is malleable throughout the lifespan. Of course, the rate of this changes differs over the years. When we talk about children, they are more prone to show the changes, and there is a possibility of neural reorganization or remapping, which can occur in response to injury or learning, even in mature nervous system. And there are evidences as mentioned in the slide. In addition to that, long-term potentiation, that is long-lasting increase in synaptic transmission, and evidences also shows that based on the experience and the stimulation, because of that, there is a changes which is happening in the cardiac structure, and that improve the synaptic efficiency and increase the neural density. And you can see the right-hand side where it shows that over the years in children, how the neural density is changing because of synapses formation and synaptic pruning. There are certain assumptions if you believe that training works in these children, and these are the 4 assumptions we have to keep in mind. And the assumption, first one is auditory processes and skills support listening, language use. The second one is you believe that APD test can identify deficient auditory processes, because I'm sure most of you are aware of it. Whenever you wanted to diagnose APD, you have to use the test battery approach, a series of tests after finishing the basic audiological evaluation. So you have to believe that your test is sensitive enough to tap the different auditory processes. Available treatment can target the deficient auditory processes. This is the third assumption. And the fourth one is intervention improves auditory processes and reduce functional deficits. Remember, whatever we deal with through the training, it's not the structural changes in the auditory system, it's more of functional changes which we can expect, and that's what the fMRI and EEG studies talks about it, and I will be throwing some light on some of the studies what we did in our lab. So globally, there are the computer-based auditory training program or the software which is available, but these are the commercially available like Fast Forward or the Aerobics, and they are targeted to temporal processing and auditory pattern recognitions. This is one of the review articles what I could come across published in 2010 in Developmental Medicine and Child Neurology, where they showed that the computer-based auditory training benefit not only for the CAPD children, but also for children with language and reading-related learning difficulties. And most of the article, whatever they shortlisted in this review article by Lou and their colleague, they try to evaluate the extent it can benefit children with APD. So they explored in between 2000 to 2008, and they shortlisted 16 studies based on their inclusion criteria. And out of those 16 studies, 13 were used the Fast Forward software, whereas 3 used aerobic software. So what is Fast Forward? If any one of you used it and you wanted to look at it, this was developed by Dr. Talal and their team in 1997 and marketed by Scientific Learning Corporation, USA. This is an adaptive intervention program. This particular software is having an activities where acoustically modified non-speech sounds was used, something like elongated tones, the different pure tones they were prolonged, or the different speech sounds they were slowed down in terms of rate, and that's how they were able to use on language learning impairment children. And this was designed to train temporal processing, speech perception, and language comprehension skills. But then the limitations with this particular software in Indian population, when it is speech-based sounds, the dialect and the accent, and that limits the usage of this particular software in Indian population. You can see here, these are the 13 studies they quoted, and what I highlighted here, they tried to look at it, one of the domain, and that was auditory processing, whether it improved or not with this particular, fast forward training module. And you can see that they could be able to see most of the studies there, even the auditory processing areas was also showing an improvement. The next is the aerobic. This is also commercially available softwares, which is a comprehensive computer-based program for training in phonological awareness and auditory language processing. The activities was aimed to improve sound awareness, discrimination of sound in noise and quiet, sequencing sound, associating sound with letters, understanding of complex directions with and without background noise, and memory for sounds and words. And this includes strengthening the reading, spelling, and comprehension. So along with the auditory processing domain, even it also looks after, some of the activities are targeted to reading and spelling domain as well. And this is what here also this particular training module do have speech and non-speech based tasks, and this is where it limits in Indian population, but this particular software is also there, commercially available, which we can purchase, and non-speech based tokens we can use it if you think it works out for your targeted population. So in this particular review article, there were these 3 articles where they could see that aerobic was the software used, and it was beneficial for auditory processing domain based on the speech about ABR and speech about cortical potential in quiet and noise. So that gives some evidences that yes, training works, and even for APD and other comorbid conditions. This is another article what I could come across, which was published in Seminar Hearing 2015, where they tried to look at it, the level of evidence for studies, which is investigating the efficacy of auditory training in patients with auditory complaint. And you can see that right hand side, there are a series of articles which was published, in between before 2015, and level 1 is one of the best quality of article, the rigorous method, that is the cohort study, where they use the double-blind and randomized controlled trial, the one of the best possible research design. Whereas the level 5 is, based on the expert clinical opinion, but you can see that not a single study is reflected at level 5. Most of it is in between 1 and 4. So the fourth one is observational data. So this again gives us an confidence that yes, auditory training works in this particular population, that is in APD individuals. This is the third one article where the Lu and Kali again they worked on APD individuals. So there were 20 APD children whom they have given the computer-based auditory training for 3 months. And what they could see that once they underwent for the 3 months training, and these are the training activities which was targeted to, and they could see that there is a significant changes, and that change is retained, based on the speech and noise test pre and post comparison. In addition to that, they also look at it, the fragmented profile, and what they could see that those APD individuals who were not trained were not having any changes, whereas those who underwent the training, there is a significant changes. So this is another evidence globally that computer-based auditory training works in these individuals. Now with that, I will be sharing a couple of slides, whatever study we pursued it. And Dr. Neelas is also one of the team. We are working together from last 1.5 decades, and we try to look at it. One side is the balance, and other side is auditory processing. So almost around more than 2.5 crores project till now we could able to do it, exploring these 2 areas. So this is one of the project where intramural project based research fund, that is AR project we say. This is an intramural project where our institute spent some grants, somewhere around 5 to 6 lakhs rupees for the manpower, and rest of the infrastructure we use it. So me and Dr. Neelas worked on this particular project where we try to look at it, how the computer-based auditory training, whether it is effective or not. And the material what we use, as I said, aerobic software was there with us in our department, and we use it. That material, along with that, some of the indigenous material, that is computer-assisted auditory training, which was targeted for discrimination, identification, and comprehension tasks. And as an outcome measure, we look at it, some of the psychophysical tests, that is behavioral assessment, and the electrophysiological tests to have better evidences if there is any changes. So let's quickly have a look at it. What was the finding? Almost around 935 children with normal hearing in the different school in and around Mysore. We tried to look at it in between 8 to 12 years of age. And initially, we have to run, these are the series of tests what was done. You can see the left hand side, starting with the questionnaire-based, checklist, then audiological screening, that is SCAP. Wait, it's moving, I'm sorry. So the first one is SCAP, which is a screening checklist for auditory processing. The next one is the screening test for auditory processing, and then we have to rule out, cognition, language, and reading abilities. Because if you don't rule out, then you really don't know whether you are dealing with comorbid conditions or you are dealing with APD alone. So that's where MMSC, that is mini-mental state examination, banks language screening test, and early reading skill test helped me to rule out cognition, language, and reading respectively. Then the basic audiological evaluation to rule out any peripheral hearing loss, electrocardiogram pathology, and then it comes, the differential diagnosis of the confirmation of APD. And the confirmation of APD, you have to have, a series of tests again. both speech and non-speech based trials. So here I use speech in noise, diabetic CV, and gap detection. And based on the ASHA criteria, you have to have mean plus minus 2 ST, and recently in our India, Yatiras and Vanessa, they come out with the diagnostic criteria of mean plus minus 1 ST and 2 ST. So by keeping in mind both the criteria, we find out the baseline and then pre and post measure using both behavioral and electrophysiological measure. So what we could say So what we could see, why it's moving so fast. So speech and noise test, if you see here, there are 4 evaluations. One is, the first one, blue bar is baseline. Green one is your immediately after the training, and we could see the significant changes. Later, we wanted to look at it, whatever changes it happened, whether it is, just by chance there is some changes, or it is because of the training, and how far there is a retention. So this is where the evaluation 3 and evaluation 4, that is, after the cessation of the training, 1 week and 1 month, how do they do it? And what we could see that there is a slight drop in the score, but then still it is way ahead from the baseline, and the retention is there up to 1 month, and that's really encouraging for us to see that yes, there is a changes in the training, and it really works. Same thing we could able to see even for the pitch discrimination test, that there is a retention and there is an improvement after the training, and even for the gap detection test, as well as temporal modulation transfer function. So these are the 4 behavioral measures. When it comes to the electrophysiological measure, as I said, there were 2 tests, that was speech ABR and speech LLR. And what we could see, speech ABR, there were no differences with reference to before and after training. There were slight changes in the mean, but not significantly different. But the cortical potential, we could able to see the differences. As you can see here, P1 and 1, P2, and there is a significant differences which is reflected here in P1 and N2, and that was encouraging, and that's where we could able to extrapolate that cortical structures, though the number of training was given was just 10 to 12 sessions in the span of 1 month, but then cortical structure could able to reflect some of the changes, and that supported the behavioral measures as well. Whereas speech ABR, which is more of the upper brainstem and the subcortical structures, we could not see any changes, much changes in those structures. So probably when we explore the literature, what we could realize that if we wanted to look at it, subcortical structure, we have to have longer duration of training to ensure that whether there is a change is getting reflected or not. So then we could be able to see that there are several studies reported in the literature in APV as well as in other comorbid conditions like learning impairment and reading difficulties. So that was really encouraging, and based on that encouraging data, we go forward for the extramural grants. And I'm happy to share with you that Department of Science and Technology could be able to consider our project. I'm sorry for the typographical error. So we got the grants for this particular project, where we tried to design the computer-based auditory training module on auditory and cognition, cognitive skill in children with APD. So here what we try to do is, as you know, there are different processes like temporal processing, auditory closure, binaural integration, binaural separation, binaural interaction, and auditory memory and sequencing. So here we try to customize, keeping in mind the Indian population, the different module, and we try to look at it, how do they do it. Of course, it's not commercially available. We have to follow certain procedure at the institute level to come out with, all of you to give an access of this particular training module. But we could able to do the validation of this module. This is how it looks like. This is the closed set task where, since it is targeted to children, it has to be interactive, it has to be adaptive, it has to be, interesting for the children. So this is where we customize it, with the pictures. There are 6 options. Out of that, 1 is the keyword, and they need to select the keyword. And for every token, there is some feedback that whether you have done correctly or there is, wrong responses. If there is a wrong response, you are encouraged to make an attempt again and again. So again, this is what the series of tests, what you have to do it if you are looking at it, the conformed APD cases for training. In this particular data sample, in this cohort, the research project staff, Dr. Risha, she was working here as a PhD scholar, and she could able to, give us a fabulous data in this particular project. So we could able to see, that 10 APD children, they underwent a training for in between 8 to 16 session, and in addition to the audiological, that is auditory processing test, we also consider the cognitive measure, that is digit span test, forward and backward digit span, and the ascending and descending digit span test. And here again, we considered behavioral test, as I said earlier, speech in noise in Indian English, gap detection test, duration pattern, diacritic CV, and memory and sequencing test, in addition to speech ADR and speech LLR. So I already explained you about the CD80 module. So how it was, like this auditory closure task here, the stimuli was presented, using the plus 20 dB SNR and minus 4 dB SNR. It was changing in this particular sequence depending upon the response get it from the child. And there were two different tokens. One was the trisyllabic words, other one was the monosyllabic words, and there were two different kind of noise. One was speech-shaped noise, and other one was multi-talker babble. You know that multi-talker babble is the most difficult situation, and if you compare between the trisyllabic and monosyllabic is the most difficult. So this is how the sequence of the the training goes on. Initially, it's the easiest one, and moving towards the most difficult one. This is the number of training. All these 10 participants, they participated in between 8 to 16, depending upon their abilities and their performance. So let's have a look at results. What we could see that most of the behavioral measures, not only the speech and noise measures, even the temporal processing, we could able to see the significant changes. However, we couldn't see the differences much in terms of memory and sequencing and diacritic CV. And I will show you the individual data where you can see that this particular graph tells you about the blue color diamond set, that is the baseline. And two lines, that is the normative range, mean plus minus 2 ST. And what we could see that after training, the triangle one, that is the immediately post one, and you can see that they could be able to achieve their performance well within the normative range, except a couple of participants, like in this particular one, you can see participant number 1 and 2, even though there is an improvement, but they could not achieve the normative values. So, but then most of them, they could be able to do it. Out of 10, 8 could be able to achieve the normative values. Same thing we could be able to see even for gap detection as well as for duration pattern. And diacritic CV, as I said, not a great differences we could notice. And when we look at it, cognitive domain, even in cognitive domain, except the forward span, the backward and ascending and descending, there was some significant improvement after training. And when we look at the literature, what we could see that they say the lack of improvement in the forward digit span probably could be due to limitations in tapping short-term memory, the kind of training they underwent, not able to facilitate the short-term memory, but then only work with working memory. And this is where we could able to see the differences only in the backward and ascending and descending, not the digit forward task. When we look at it in this particular project as well in speech evoked ABR, we didn't see much differences. Let me tell you, this is a multi-channel ERP where natural stimuli DAW was used, not the linear cross 40 millisecond DAW stimuli. So that's where you can see the time window and the waveform are slightly different than typically you see in biomark. Whereas in the cortical potential, that auditory latency responses, we could able to see that there is differences before and after training. This is a grand mean average, and you can see that there is a differences in quite as well as in noise in comparison to the baseline. Since it was a multi-channel ERP, we had a lot of data to explore, and we tried to look at it, looking at the brain mapping and the scalp distribution. And what we could see that we tried to look at the global field power by using the Curry software, those who are using the multi-channel ERP and offline analysis will be able to extrapolate these interpretations. So what we could able to see that from the baseline, there is changes which is getting reflected. You can see here blue and red combinations, which are the different random map in the quiet as well as in the in noise in the experimental group. And this very clearly shows that the cortical structure do have some changes, which is getting reflected, stronger and stronger with the training, and such changes are not reflected in control APD group, those who are not exposed to this particular computer-based auditory training. And that's what we could able to see even in the literature as well, that individuals are benefited in the cortical structure. And based on this particular project outcome, same is published in Index Journal. This is in American Journal of Audiology. Other one is in International Journal of Pediatric Otolaryngology. And this is right now, Naina, she is a PhD scholar working on temporal processing domain using this computer-based auditory training software. I will not share much of the data since her PhD is still going on. But I will just share you one of the publications recently, last year she published, and this is an utility of deficit-specific computer-based training on children with temporal processing deficit. This is a similar, the prototype of research design. You can see the series of tests, what is done. Here, there is one thing which was added based on the research advisory committee. They asked, how do you know that, that training only is working and not that anything else? So they asked us to have one more group, that is the placebo group. So you can see that the second one is the placebo group, and this particular group was exposed to computer game, but not the training module what we designed, which is in this, the deficit-specific design. Along with typically developing children and the active CAPD children. So what we could able to see here, if you look at it, this behavioral measure, there were 4 tests what we administered here. One was the gap detection test, another one was duration pattern test, third one was the diacritic CV and speech in noise. The training was targeted to temporal processing domain, and you can see that active group, the first one, there is a reduction in gap detection threshold which is significant, and same changes you don't see for placebo group as well as typically developing children who typically developing children were not exposed to the training, any kind of training during that period, whereas placebo group were exposed to computer-based game, but not the training which was customized for this particular study. And we don't see any changes with that. So this gives an, another level of evidence that anything don't work, you have to have the training which is customized for your targeted group, and that's what it works. Not any kind of game that is going to help them to make the functional changes in those individuals who are having processing deficit. So these improvements in the temporal processing score can be attributed to auditory learning induced due to training. Probably there is a reorganization of the auditory cortex, maturation and neuroplasticity. A repeated stimulation used in this computer-based temporal processing training module probably led to a strengthening of the neural responses over a period in the auditory pathway, and could also be retained due to long-term potentiation. And this long-term potentiation could lead to change in the neurons, which in turn are reflected as a change in the score of CAPD test post-training. So take-home message is not anything works. It's a deficit-specific training which is more effective. And in deficit-specific training, computer-based auditory training is giving you a lot of evidence that in today's day it works with the minimal involvement of professionals working with them, and you can recommend ask them to do it, the practices at home as well. But of course, you have to supervise them. How do they do it? And you have to have data to look at it. How do they progress? So at the end, I would like to thank the organizing committee for giving me an opportunity. I would like to thank my alma mater, All India Institute of Speech and Hearing, our beloved director, Professor M. Puspavati, for giving me an permission to come and attend and carry out this study. Department of Science and Technology for funding us and come out with some evidence-based practices in APD individuals. For more details, if you wanted to have a look at it, you can go through our research profile in the Google Scholar as well as LinkedIn. Happy to take up any questions. Thank you.
Thank you, Dr. Praveen, for giving us a summary of whatever information is available regarding the computer-based auditory training globally, and also showing us some of your studies. I think we have about a minute and a half for any questions, so if there is any question, we can take it up.
Gap detection, madam, here what we used it, this is yeah, madam is asking what exactly you did it for the gap detection test and the changes what you see with the training, right?
Which aspects you saw the change? More than, okay, just your cognitive-based deficit, which you report, which the paper you showed, the
Ma'am, cognitive deficit was not
no,
considered here.
not cognitive. Deficit-based training. I'm
Correct,
sorry.
correct.
In that, we did on only temporal, right?
Yes.
So, which aspects improve first and which, I mean, because you've seen.
Okay, I got your point, madam. So, madam is asking which aspect improved first. What I wanted to add on here, I think madam wanted to know, since we considered different domain, the test, APT test was targeted to different domain, like the speech in noise, which is an auditory closure task, or you can say monaural low redundancy task. Whereas the temporal processing like GDT and TMTF, which is more of temporal resolution, right? The third one is the diacritic CV, which is more of binary integration, which is slightly at the higher end in another domain what it is. What we could see here, even in the first, the process outcome, as well as the second one, both the PhD scholars, what they reported, though we had given training which was targeted to auditory closure domain, that is auditory separation domain, but then the changes is reflected even in the temporal processing domain as well. So that means there is no rigid boundary between the two processes. This is what in literature we could be able to see that, and there are many studies where they could see that when you are working on one domain, there is a changes which is happening to the other domain as well, and exclusively the temporal processing domain do reflect the changes. Whereas the binary integration, we didn't see much encouraging changes with this particular module. The second one, the article that Naina, who is working right now, her training was targeted to temporal domain, where we had gap detection, training module. There, what happens is, I can give you one of the examples. Say, for example, I'm asking you, tell me whether silence is there or not between the stimulus. And say, for example, this is a buzz. Now, the second one is having the gap. The second one is having the gap. First one is having the gap. Now, here what is happening? I'm giving a pause in between. This pause is nothing, this silence is nothing, it's a gap. Our auditory structure could be able to detect even 2 to 3 milliseconds of gap. And I'm sure most of you will be there with me that VOT, voice onset time, when we are asking ka and ka, the differences is aspiration. So these minor basic cues, what is there, which is very, very important for recognitions, and we have to have this particular set of skills to identify what exactly is the token. So normal hearing individuals could be able to do it. Even one of the study where we could see that even the 70 years and above, they do as good as adults and other individuals when it comes to this gap detection, 2 to 3 milliseconds. Of course, there are many modifications in gap detection tests, like you have gapping noise, there is a within channel, between channel, etc. The experimental paradigms G4, but then we could be able to do well. Those individuals like ANSD individuals, they have the larger gap, So those individuals don't show much changes when we enroll them for the training. Yes, ma'am. I hope I answered your questions.
Yeah.
The hierarchy we
Happy
didn't look
to
at.
get it published, though you said APD, because I just saw an editorial in here and here, in the sense a recent editorial, where they said APD we will not accept if you diagnose as APD. And that's not, I mean, in my view, APD exists, but I'm happy you got it published.
Okay, very nice. Thank you, madam. I think we need to understand. Recently, I'm very well aware of it. There is a lot of discussion is going on. This is the two school of thought. One believe that okay, APD is because of speech language learning.
Dr. Praveen,
Yeah.
We would like to have some more questions during tea break.
Yeah, sure.
Huh? Thank you very much for your nice presentation.
Thank you.
Though I was late and I was in traffic jam, but I joined later and I saw it was, you are working very hard for the project, and I wish you good luck.